Life on Earth once hosted creatures that were far more different than those we see today. Some were unimaginably large, while others were incredibly skilled and adapted beings. However, a very large portion of these life forms were wiped out by a meteor that struck Earth at extremely high speed and by the subsequent processes that followed. So why did this meteor fall to Earth? What are the types of meteors? And why are we not experiencing such a large-scale meteor bombardment in recent times? In this video, we will answer all of these questions together. But before we get into it, if you enjoy this type of content, don't forget to hit the like button, subscribe to support me, and leave a comment to share your thoughts about the video. Now, if you're ready, let's dive into our video in detail. Although our solar system may appear calm, orderly, and as if everything is perfectly fine when viewed from the outside, in reality, when we look deeper and examine it in detail, it is a highly dynamic, chaotic, and constantly changing system. Since its formation, approximately 4.5 billion years have passed, and during this time, planets were not shaped only through gravitational interactions, but also through countless collisions, fragmentation events, and reaccumulation processes. Especially during the early formation period of the system, objects that existed in space and could not merge into planets gradually entered the gravitational influence of young planets, orbiting them for long periods and eventually colliding with their surfaces. Of course, some of these collisions went far beyond ordinary meteor impacts. The best example of this is our own planet Earth. According to scientific estimates, Earth collided with a Mars-sized planet of unknown origin called Theia, and as a result of this massive impact, the Moon, our constant companion today, was formed. In this context, meteorite impacts are not merely random surface-marking events, but fundamental mechanisms that play a decisive role in the evolution of planets. The arrival of meteoritic material to Earth is a process that dates back to the early stages of the solar system. In the early phases of planetary formation, within what is called the protoplanetary disk, a cloud of gas and dust, particles gradually combined to form larger bodies. However, this process was not fully efficient, leaving behind a significant amount of leftover material. The objects we today call meteoroids are essentially the remnants of this early planetary formation process that never fully completed. Most of these objects are now located in what you likely know as the asteroid belt. The rest originate from comets. The asteroid belt is located between the orbits of Mars and Jupiter and contains millions of rocky fragments of various sizes. These objects could not fully form a planet, mainly due to the strong gravitational influence of Jupiter, and therefore remained in a fragmented state. Over time, however, these fragments interacted and collided with each other, forming smaller meteoroids. Comets, on the other hand, have a very different structure. Composed of ice, dust, and organic compounds, these bodies lose their volatile materials as they approach the Sun, leaving behind a dense trail of particles. The beautiful tail we observe from Earth is actually this particle trail. Over time, these particles form meteoroid streams. When Earth's orbit intersects with these streams, meteor showers occur. However, these events are generally limited to microscopic particles and do not cause any destructive effects on the planet. You know, every object in the solar system moves along a specific orbit. However, these orbits are never truly stable. Especially the strong gravitational fields of large planets, most notably Jupiter, can significantly influence the trajectories of smaller bodies and push them into highly irregular paths. When the orbit of a meteoroid is altered due to a collision or a gravitational interaction, it is forced out of its stable path around the Sun and enters a chaotic trajectory. If this new path intersects with Earth's orbit, a collision becomes inevitable. However, not every meteoroid ends up hitting our planet because Earth has a kind of protective shield, its atmosphere. Earth's atmosphere plays a crucial role when it comes to meteors. It acts as a natural shield that protects the planet from small and medium-sized meteoroids. A meteoroid entering the atmosphere travels at speeds ranging from approximately 11 to 72 kilometers per second, far beyond anything any human-made object can achieve. When a meteoroid enters the atmosphere, it does not actually burn due to simple friction, as is commonly explained. Instead, the real reason is the extreme heating caused by the sudden compression of air molecules in front of it. In other words, while friction and air compression are related phenomena, Focusing only on friction is a misleading oversimplification that is often repeated incorrectly. As the meteoroid begins to heat up, its surface rapidly melts and vaporizes. This process is called ablation. During ablation, the ionized gas layer formed around the meteoroid emits a bright orange glow, and this is what we observe as a meteor. Most meteoroids are completely destroyed at this stage, but larger or denser ones can survive, slow down as they fragment in the atmosphere, and eventually reach the surface. At that point, they are called meteorites. Although large meteor impacts are rare today, small meteorites still reach Earth every year. In fact, one of the most recent recorded meteorite impacts pierced the roof of a house and landed in a bedroom. When we examine the physical structure of meteorites, we see that they carry extremely important information about the early solar system. Scientists study these objects to make conclusions about the earliest periods of planetary formation. In fact, based on these studies, it is now suggested that both life and water on Earth may have been delivered by meteorites. In other words, according to this idea, we might actually be spaceborne, in a sense. Meteorites are generally divided into three main categories: stony iron and stony iron meteorites. Stony meteorites are composed of silicate minerals and are the most common type. Iron meteorites contain a high percentage of iron and nickel and are extremely dense. They are usually fragments from the cores of larger celestial bodies. Stony iron meteorites contain both structures and are much rarer. This diversity is one of the strongest indicators that meteorites have different origins. Some are fragments broken off from the surfaces of asteroids, while others come from the internal structures of much larger bodies. In fact, some meteorites have been confirmed to originate from Mars and even the Moon. This means that some objects come from planets and moons much closer to us than we might expect. This also shows that in the past, massive collisions on these celestial bodies ejected material into space, and over time, this material eventually reached Earth. There are several important reasons why our planet does not experience frequent large meteor impacts. First, the size distribution of objects in space is highly uneven. Large objects are, contrary to what many people assume, extremely rare. Second, the atmosphere effectively destroys small and medium-sized objects. Third, the solar system has become largely stable in its current dynamic configuration. And finally, giant planets like Jupiter either capture many potential threats or alter their orbits, sending them away from Earth. For this reason, Jupiter is often described as a cosmic shield. If Jupiter did not exist, or if it were a much smaller planet, our world and even our moon might be constantly exposed to meteor bombardments. In such a scenario, life on Earth might never have developed, or if it had, it would likely have been extremely short-lived. However, these protective mechanisms are not absolute. Geological records show us that in the past, Earth experienced much more intense bombardment by collisions, especially during the period known as the Late Heavy Bombardment. Around 4 billion years ago, the inner planets were constantly struck by large objects. This period played a very important role in shaping planetary surfaces. One of the most dramatic consequences of these impacts was the extinction of the dinosaurs. About 66 million years ago, Earth experienced a massive collision. This impact not only changed the planet's biological diversity, but also fundamentally transformed its atmospheric and climatic systems. An asteroid estimated to be about 10 kilometers in diameter struck Earth at extremely high speed. The energy released by the impact was equivalent to billions of atomic bombs combined. This collision caused global wildfires, enormous shock waves, and the formation of dense dust clouds in the atmosphere. The dust and sulfate particles released into the atmosphere significantly blocked sunlight from reaching Earth's surface, and a long-lasting period of darkness began. During this time, photosynthesis nearly came to a halt, plants rapidly disappeared, and as a result, the entire food chain collapsed. Large, energy-demanding creatures such as dinosaurs were among the most affected species. Although many people believe that dinosaurs were instantly destroyed at the moment of impact, in reality, it was the post-impact environmental collapse that led to their true extinction. Of course, many species were wiped out during the collision itself, and the populations of surviving species were drastically reduced. However, complete immediate extinction did not occur. After the impact, surviving dinosaurs were forced to migrate to unfamiliar regions and spent long periods searching for food sources. Unfortunately, due to the lack of sufficient nutrition and the complete halt in reproduction, their populations eventually disappeared entirely. In addition to dinosaurs, many other predators and species affected by the post-impact conditions were also erased from the face of the Earth. This clearly demonstrates how meteoroid impacts can have not only physical, but also devastating biological consequences. Today, although the probability of such a large impact is very low, it is not completely impossible. For this reason, scientists have been continuously monitoring near-Earth asteroids for many years and trying to identify potential threats. Current data shows that Earth is still a cosmic target and continues to interact with objects coming from space. Even though we are largely protected thanks to our atmosphere and other shielding factors, complete elimination of such collisions is impossible due to the nature of the solar system. As mentioned, scientists are also developing various methods to prepare for such events. For example, there have been experimental ideas such as sending spacecraft to the surface of an incoming asteroid and slightly shifting its orbit using explosive devices or similar techniques. Although this may sound utopian, it is not impossible. In fact, NASA achieved success in such experiments in 2022. In September 2022, through its DART mission, it successfully altered the orbit of the asteroid Dimorphos. In doing so, humanity achieved a historic first by intentionally changing the motion of a celestial object. A spacecraft traveling at approximately 23,000 kilometers per hour collided with the 170-meter-wide asteroid, reducing its orbital path around the larger asteroid Didymos. As a result of the impact, Dimorphos's orbital period was shortened by 32 minutes and its orbit was altered. Additionally, the collision affected not only the smaller asteroid Dimorphos, but also the larger asteroid Didymos, influencing the overall system's orbit around the Sun. In other words, as we can see, humanity is not only relying on natural protective shields, but is also developing systems to actively defend itself. Looking at Earth's interaction with meteoroids today, we see impacts occurring at a much lower intensity compared to the massive collisions of the past. However, let me remind you once again that this does not mean the planet is safe in a cosmic sense. On the contrary, thanks to modern observation techniques, we now know that Earth is constantly interacting with particles coming from space. Measurements show us that approximately 40 to 50 tons of cosmic material enter Earth's atmosphere every day. The vast majority of this material consists of microscopic dust particles, which burn up completely in the atmosphere and disappear. However, from time to time, larger objects also enter the atmosphere. Such events have been studied in much greater detail thanks to observation systems developed in the last century. One of the most remarkable meteor events recorded in modern times occurred 118 years ago in 1908 in the Tunguska region of Siberia. The explosion was caused by a celestial object estimated to be 50 to 60 meters in diameter, which exploded before reaching the Earth's surface after entering the atmosphere. These types of explosions are called airbursts, and although they do not reach the ground, they can still be extremely destructive. For example, in the Tunguska event, the released energy was estimated to be equivalent to 10 to 15 megatons of TNT. This is hundreds of times more powerful than the atomic bomb dropped on Hiroshima. As a result of the explosion, an area of approximately 2,000 square kilometers of forest was completely flattened and millions of trees were uprooted. Interestingly, despite such massive destruction, no clear impact crater was found on the ground. This actually proves that the explosion occurred in the atmosphere. A similar event took place in 2013 over the city of Chelyabinsk in Russia. A meteoroid approximately 20 meters in diameter entered the atmosphere and exploded at an altitude of about 30 kilometers above the ground. This explosion created a powerful shockwave that shattered the windows of buildings across the city. Around 1,500 people were injured in this event, demonstrating how even relatively small cosmic objects can make modern cities vulnerable. When the statistical distribution of such events is analyzed, we can get a general idea of how frequently objects of different sizes collide with Earth. Meteoroids about 1 meter in diameter enter the atmosphere almost every day, while objects around 10 meters in diameter are observed once every few years. Larger objects around 50 meters in diameter occur roughly once per century. Giant asteroid impacts like the Chicxulub event that wiped out the dinosaurs are estimated to occur once every millions of years. Once again, these low probabilities do not mean that Earth is completely safe. For this reason, modern science not only identifies potential threats, but also develops strategies to intervene when necessary. Near-Earth objects, known as NEOs, are continuously monitored through special telescopes and space missions. Thanks to detailed calculations, The probability of these objects colliding with Earth can be determined. To date, thousands of NEOs have been discovered, and it has been confirmed that the vast majority of them do not pose a short or medium-term impact risk. However, it is also known that many objects still remain undiscovered. And that's it, my dear friends. Our planet, along with many others in the solar system, experienced intense meteor bombardment in its early history. Thanks to its natural protective mechanisms, Earth has been largely shielded from large asteroid impacts for a very long time. However, no matter what, we must continue improving our technology every day so that we are not caught unprepared in the event of sudden developments and to take precautions against all kinds of disasters. My trust in scientists at this point is absolute. Perhaps in the future, thanks to our technology, we will even be able to capture some asteroids and make use of their resources. Although this may sound utopian to many people, one of the most important steps in the development of human civilization is actually the ability to utilize the resources in our solar system as efficiently as possible. Because of this, instead of targeting large objects at first, we could start by targeting smaller ones, keeping them in a safe orbit around us and benefiting from their resources. Anyway, my friends, I hope you enjoyed the video. That's all from me for today. If you liked the video, don't forget to hit the like button, subscribe to support me, and leave your thoughts about the video in the comments. See you in the next video. Take very good care of yourselves. Goodbye.